In this video, we will discuss how to architect AWS infrastructure and what are the best practices that we can follow to get the maximum out of AWS. So, while migrating applications to AWS, even without significant changes and the approach that is known as lift and shift, it provides organizations the benefits of a secured and cost efficient infrastructure. However, to make the most of the elasticity and agility possible with cloud computing, engineers will have to evolve their architectures to take advantage of the AWS capabilities. For new applications, AWS customers have been discovering cloud specific IT architecture patterns, driving even more efficiency and scalability. And those new architectures can support anything from real-time analytics of internet scale data to applications with unpredictable traffic from thousands of connected internet of things or mobile devices. So this video will like to highlight the principles to consider whether you are migrating existing applications to AWS or designing new applications for the cloud. This video assumes that you will be having basic understanding of AWS services and solutions. So before starting this series, I would suggest to go through the previous videos so that you have better idea of the AWS services and how they work. Now, what is the difference like from on-premise infrastructure and cloud infrastructure? If you compare them, I can say in cloud, IT assets become programmable resources. What I mean is like in a non-cloud environment, you would have to provision capacity based on a guess of a theoretical maximum peak. This can result in periods where expensive resources are idle or occasions of insufficient capacity. With cloud computing, you can access as little as you need and dynamically scale to meet actual demand while only paying for what you use. So it simply means that in on-premise infrastructure, once you have bought the hardware, storage, or anything like whatever you have bought, and you have to use it like and but if there is no such peak value, there's no such demand of that particular resource, or your resources are underutilized, then you have no option. Your expensive resource is getting wasted in on-premise infrastructure. And apart from that, if the resources you have bought are overutilized or are not sufficient, you cannot just scale them. So that is another challenge. So you have to go for another resource. So the benefit with AWS is you can start with minimum resources and you can scale up to whatever you need, and you will be paying as per your usage. So that's the big benefit I can tell that the cloud is providing. So on AWS, servers, databases, storage, and high-level application components can be instantiated within seconds. You can treat these as temporary and disposable resources, free from the inflexibility and constraints of a fixed and finite IT infrastructure. This resets the way you approach change management, testing, reliability, and capacity planning. Now, the another thing that I would like to highlight is the global availability and unlimited capacity. So, using the global infrastructure of AWS, you can deploy your applications to the AWS region that best meets your requirement. For example, the proximity to your end users, compliance or data residency constraints, cost, etc. So for global applications, You can reduce latency to end users around the world by using the Amazon CloudFront Content Delivery Network. It is also much easier to operate production applications and databases across multiple data centers to achieve high availability and fault tolerance. Together with the virtually unlimited on demand capacity that is available to AWS customers, you can think differently about how to enable future expansion via your IT architecture. So it simply means that the infrastructure is global and of unlimited capacity. So you can deploy your infrastructure based on your preference, global preference, and your users demand. You can deploy your infrastructure anywhere, and you can use unlimited capacity of resources whatever you need. So that's the beauty of cloud. Now another thing is higher level managed services. So apart from the compute resources of Amazon Elastic Compute Cloud or Amazon EC2, AWS customers also have access to a broad set of storage, database, analytics, applications, and deployment services. Because these services are instantly available to developers, they reduce dependency on in house specialized skills and allow organizations to deliver new solutions faster. These services are managed by AWS, which can lower operational complexity and cost. AWS managed services are designed for scalability and high availability, so they can reduce risk for your implementations. Another thing is like security built in. So on traditional IT infrastructure, security auditing would be a periodic and manual process. The AWS cloud instead provide governance capabilities that enable continuous monitoring of configuration changes to your IT resources. And since AWS assets are programmable resources, your security policy can be formalized and embedded with the design of your infrastructure. With the ability to spin up temporary environments, security testing can now become part of your continuous delivery pipeline. Finally, solution architects can leverage a plethora of native AWS security and encryption features that can help achieve higher level of data protection and compliance. So this was the introduction of how we are going to migrate our infrastructure from on-premise to cloud and what are the things we can keep in mind while doing that. So thank you for listening.